Alright, this is going to be a quick video of the 9-1B worksheet, just showing you the answers. This first page, and I'll try to hook up just a picture of the pages and the answers along with this video, so you don't have to watch the whole video unless you want to watch parts of it to get an explanation. The first page is just where estimates here and actual ages here, which so you could have just about anything. Some of the people, like if you look down here, Sergio Ramos, I had no idea who that was, and I guessed that they were 60. And he's actually 34. You guys probably knew who that was, and I have no clue. But then here in the middle, I actually got 3 in a row exactly right, and I didn't cheat. But those are the only ones I was really close to. So I'm going to draw the scatter plot for this. Just matching these up. Our first point would be 52, 57. Just matching those up. My next point would be 30, 26. And I'm going to draw that scatter plot. Alright, here's my scatter plot. And I've actually typed all those ages, the estimated age and the actual age, into my calculator, and I'm going to go ahead and do 4 through 7 down here. 5 through 7 we're actually going to use a calculator. It says draw a line of best fit for the data. The line will go through 2 points and split the rest of the data evenly. My line of best fit might be maybe something like that. There's about 1, 2, 3, 4, 5 on the bottom side. 1, 2, 3, 4 on the top side. Well, there's 6 on the bottom side maybe, but that's about as close as I'm going to get. Notice that it's sort of just scattered everywhere. It's not really, doesn't look like it's really completely linear. Next thing we're going to do is we're going to go on the calculator. We're going to hit stat, go to calculate, go down to the linear regression, AX plus B, hit enter, and I put mine in on 5 and 6. So second 5, comma, second 6. Then I'm going to hit enter, and it should pull up your A, your B, your R squared, and your R. And those are the answers to, come down here, those are the answers to 5, 6, and 7. I have to move this off to the side somehow. 5 says look at the line of best fit. What is your y-intercept? We could have found our y-intercept by going up here somewhere and trying to find it, but we use the calculator, and that's our B, and it says it's 12 point we'll round that off to 12.18. Again, your answers here are probably going to be different than my answers. Something's wrong if you got the exact same guesses that I had. Then our slope is 0.719, or we'll say about 0.72. And then to write our equation, we just use those two. Again, this is your y-intercept, this is your slope. So it's going to be y hat equals 0.72 x plus 12.18. Then our R is right here, which is about 0.694, let's say. So that's the first page. Again, your answer is probably a little different than mine, but some just give you a general idea of how to do it. One other thing I wanted to say about this page, with our R down here, again, remember R tells you the strength and the direction. So the R is telling us that our linear regression line, or our line of best fit, is going in the positive direction, and the strength is about 0.69. So it looks like there's a little bit of correlation there, but not a whole lot. And on the next worksheet, when we get to R squared, if you look at R squared, our R squared was somewhere about 3 point something or 0.3 something, and that sort of tells us that it's not really a very strong correlation. So this isn't a real strong correlation, and we were guessing, so that's why it wasn't a real strong correlation. All right, on this second page, they want us to state whether it's positive correlation or negative correlation. If possible, draw a line that closely fits. So draw the line of best fit or linear regression line. Write an equation of the line and find R, and we're going to use our calculator for that stuff. But just looking at this one looks like maybe it has a positive correlation. If you put negative on that, I probably wouldn't mark it wrong, because it doesn't really look like there's any correlation to these points. They sort of look like they're scattered all around. And with only 6 points, it's sort of hard on all of these, but we'll just go with it. If I use my calculator, I punch these in, go to stat, calculate, go down to linear regression. I put mine in on list 1, comma, list 2, hit equals, and it tells me my A is 0.229, my B is 4.5, and then it's got R and R squared. So the equation, y hat equals, the slope is the A, so 0.229 x plus our B is 4.53. That's the equation for our line of best fit, or our linear regression line. And then it also said find R, and I had a better worksheet made out for this, and apparently I printed off the wrong one when I sent it to you guys. R is 0.124. Notice a very, very small R. Remember, R goes from -1 to 1. The closer you are to 1, the better perfect positive correlation you have. The closer you are to -1, the better perfect negative correlation you have. And the closer you are to 0, that means you're getting real close to where there is no correlation whatsoever. And on this one, we're pretty close to 0 in here somewhere. So that means that these points on our graph here have almost no correlation to each other. So X and Y really aren't related to each other. Next one, I graphed it again. Looks like it's got a, if we were to draw a line of best fit in here, it might go somewhere like right in through here somewhere. So it's got a positive correlation. Going to write our line of regression, our equation for our line of regression. Go to stat again. I already plugged these into my calculator. I go down to linear regression, and I plug them into 4 or 3 and 4. So second 3, comma, second 4, hit equals, and I get this information. So our slope is 1.09 times x. Our B is 3.6. We'll say 3.61. Notice it's got a positive slope. That's where this positive comes in. Slope's positive, so it's telling us it's going up from the left to the right. And then our R is 0.837. Notice how big this is compared to that. It's a lot closer to 1, positive 1. So that means it does look like that there is some correlation to the X's and Y's this time. Right, on this third one, problem 10, you look at this, I've graphed them. They look like they got a pretty good, like we could draw a pretty good line of regression in here. Maybe something like that. Line's probably not exactly right, but somewhere close. And it looks like this time it has a negative correlation. So that means it's going down as you go from the left to the right. I punched them into my calculator. Again, we go to stat, calculate, go down to linear regression, hit enter. I punched them into list 1 and list 2. Hit enter, gives us that. So our y hat, our equation of our regression line, is going to equal, our slope is negative 1.54. And this negative here on this slope should match up to what you said it was. And the B is 3.23, we'll say. So it should cross the y-axis here at somewhere about 3.23, so just above 3. Ours is pretty close to, mine's pretty close to that. And then our R, I would guess, even before I look at what the calculator tells us, these numbers, when I was graphing them, it looked like that whoever made up this chart wanted it to almost form an exact line. So they should be really, really close. So our R should be really close to -1, because it's got a negative correlation and it's pretty well correlated. So if I look over here and look at our R, it's -0.996. That's really a really good correlation. And then again, if we look at R squared, which we talk about in the next lesson, R squared is 0.99. That's the one that's really telling you that whether it's if it's a good correlation or not. And when it's really close to 1 like that, that's telling you it's a really good correlation. So our X's and our Y's are related really closely on this one. Alright, on this next page, it says what is the domain of the function? Domain, remember, is your X's. Well, the domain here, we look at our X's. This is our X along the bottom. This is our Y over here. We look at our X's. It looks like we go from 1 all the way up to 8. So our domain is just 1 to 8 years. Our range is our Y's. Our Y's, it looks like we go from, let's see, these look like they start at stupid spots here. It goes 0 up to 5, so that's going to be 2.5 right there. So this would be like 7.5. And up to, we go up to, this would be 22.5 up here. So that's probably, oh well, we could just look up here. That's what I should be looking at. So it looks like it goes, 1 is 24, and then the lowest is 7. So it goes from 7, which I guess, I don't know, that point right there looks like it's halfway. It didn't look like that this side of the graph is drawn very well. So our Y's go from 7 up to 24. Should look at that first, I guess. Look at the actual data instead of the graph. And it says, what is the function type, direction, and strength? Function type, everything that we've done as far as function type goes. And this one is linear. I know I didn't really explain that real well. Now the direction and strength, this one looks like it's got a negative direction, and I would say it has a strong negative direction. So strong negative. Using technology, we found the equation of the line, so they gave you the equation, something close to that. Using the given equation, predict the value of a car that's 3.5 years old. So all that's telling you is in place of X right here, you're going to put in 3.5. So we get -2 times 3.5 plus 25. If I just take my calculator and I plug in all of that, so I plug in -2 times 3.5 plus 25. I have that in my calculator, hit equals, and it says 18. And it asks us, says using the given, predict the value of the car. So it'd be about, if it's 3.5 years old, the value would be about $18,000, because this are Y's in thousands. Then the next three just say explain each thing. So interpret the slope. The slope was right here on this -2. So it's like saying -2 over 1. And that all that's telling you is for every 1 year, each time the car gets 1 year older, it loses this top number, which is a -2, so that's where the loses comes from. It loses about $2,000 in value. The y-intercept, if we looked here, if we did draw in a line of best fit, the y-intercept, it would cross the y-axis right in here somewhere. We can also look at the equation they gave us, which it says it should have crossed at about 25, so my line of fit wasn't drawn too well. But this is the y-intercept right here. And what that tells us is that if x is 0, which would be right here on our graph, if x is 0, y would be 25. And what we're saying there is if the car is 0 years old, then its value is about $25,000. Next part says describe the relationship between the car's age and the car's value. And all we're going to say is sort of what this right here said about our slope. Each year older the car is, it will lose about $2,000 in value. Alright, the last page here, they just ask us what's the relationship in this, whether it's strong positive, strong negative, perfect positive. It's just strong negative. Since it's going down, it's going to be negative, and it's not perfect because it all be in a line, so strong negative, which would be B. Question 19. All we're going to do is take this. They want us to predict the person whose height is 169. It says a researcher has formed a relationship between the height in centimeters, which is our X, and the weight in kilograms, which is the Y. So we're just going to take that equation, negative 5.13 times the number they want this time, which is 169, stick it in there, plus 0.467. Oops, I did that wrong. Wasn't paying attention. They wrote the equation different on me. Negative 5.13 plus 0.467 times, that's where the X goes. So we plug it in there, and I'm just going to stick that right into my calculator. So I plug in negative 5.13 plus 0.467 times 169. Just have that plugged into my calculator, and it says 73.793, which is D right there. And be careful on this, because a lot of times when we're writing the regression line, and you'll notice here that they used a prime, they used Y prime instead of Y hat. Different people use different things for that. Our book says to use Y hat. Apparently whatever they're doing, they're using Y prime. I think in calculus a lot use the prime. But be careful, because a lot of times it is written with the X at the end instead of the X like you're used to in algebra. The last one here, it says the equation of a regression line between the age of a car in years and its price in reals is given by this. Notice again that the X is at the end, so this is our slope and this is our y-intercept. So if a car is 0 years old, it's going to be worth 65.3 reals. I have no idea what a real is. Probably something somebody just made up. And they just want us to tell which one actually explains that equation. So the first one says when the age of the car increases 1 year, that's our X. So when it goes up 1 year, its price decreases 65,000. Well, that's not right. The price doesn't decrease 65,000. The price is decreasing by this 9.25. So A is wrong. When the price of the car increases 1 real, so when the price of the car goes up 1 real, the age decreases by 9.25. That doesn't sound right. When the age of the car increases 1 year, its price decreases 9.25 reals on the average. That one seems right. Let's read the last one just to make sure. When the price of the car increases 1 real, the age decreases by 65.3 years. That doesn't sound right. So the answer here is C. When the age of the car goes up 1 year, that's what this slope's telling you. 9.25 compared to 1. When X goes up 1 year, the value of the car, or the price of the car, is dropping 9.25 reals. So that's just to check. Again, I'll probably send also hook on just a picture of this so that you can have it, picture of each page.